will take the beam outside and I will convert it with one of the cases given in the steel manual. This is exactly what we do. Okay, so this is even is a construction BM, but it could be very easily could be asked in the AM. So right now he's asking what is a column B2. So this is 2 and this is B. So as I told you, there's a column here and there's a column here and there's a column here. So if we take this line B as in boy, you will find like it is like this. We have 1, 2, 3, 3 slabs, 3 spans. How much is the distance between them? Is given to you. 3 feet, 3 foot, and you look at that way. So the 3 feet is given, here it is. So what I need to do, I need to get how much load, uniform load, W. I need to convert the load that now to BW. How many pounds per linear foot or kib, pound or kib, whatever. And which column he is talking about? We're talking about the B2. So this column here. I need to find the reaction if this is a B2. By looking this way. This and this will be identical, by the way. These two columns identical. And the two outside columns are identical. So this is B3, this is B1, and this is B3, and this is B4. Those are the 4 columns along the line B. Do you see that? Looking this way. You take this. This is, take all these joints and do it. Somebody may say, no, why you look at that way? Why you don't look at that way? Okay, I will look at that way. And I will come and take the line 2. So the line 2, look at that way, and the spacing here will be 5 feet, 5 feet, and also I will calculate the load like this. And I will tell you the difference between this and this. There is one keyword. This is a stringer. Here, when you look to this, when you look from the side here, what you will look, you will get the joist. These are joists. And there is one key word he mentioned here. Stringers are 2-span continuous, must consider continuity. But when the joist is a single span, simply supported. What does it mean? This stringer here, this is a stringer, like similar to the picture I showed you, is a continuous over these 3 columns, or continuous over the middle one. If you so there is so this is one member continuous. This is aesthetically indeterminate. And B2, this is what I'm looking for, B2. and this is going to be A2, and this is going to be C2, looking that way. The problem with this, these joists are not continuous. Means that if you look to this support here, you'll find that the joist is like this. There is a small line, by the way, shown here, vertical line, here it is. This is not continuous. Not continuous. This is continuous. So this is the case that is representing the reality that there is a continuous joist stringer over the column, and this, the stringers are coming this way on top of it. The joist is coming on top. So the stringer supporting the joists, the column supporting the stringer, and will take the load. So this is the case I'm going to consider in my analysis, but I explained both of them, looking both directions, which one. Okay, so right now I need to take this beam. So this beam here, which is with this stringer, sorry, let me make a word, stringer, is going to be having the half width from here and half the width from here, which is 1.5 and 1.5, 3 feet. So this W here is 3 times this 3 width. I need to get per linear foot. Is 3 times. I have 40 pounds per square foot. So 40 pounds per square foot. And this is 3 feet. So this will make it pound per linear foot. This is due to the live load, but I still have concrete. Okay, how much is the concrete will be? A plus. He said that it is 6 inch divided by 12 inch per linear foot. This is the thickness. How thick it is? Times a 3 feet wide, which is 1.5 from each side, times the 150 pound per cubic foot. Units are very important. So the 6/12 became feet. So feet and feet, this will give you pound per linear foot. If you add this plus this, will give you the total load as a distributed load. So it is 6 enter 12 divided, because 6 inch thick and a 3 feet wide and 150 times. This is 225. 225 plus 120 plus, so this will give you a 345. 3 pound per linear foot, BLF. So right now I am dealing with a beam, a continuous beam. It's two span, continuous, carrying a load of 345. Go to the steel manual, go to your book here, this summary book here, the AMBM. Let me see if I have it here. Yes, here it is. Can you look to this case here? I have a two span. This is on page 97 of the AMBM book, or if you go to the textbook, as I told you, whatever is convenient for you. Do you have this case here? This is, I am in the AMBM book, which is book number 2, page 97, book number 2. And this is, here it is. I have a uniform. W is equal to 300 and what? 345. If I did everything right. BLF. What is L? L is equal 5 feet. What is the reaction here? The reaction at B? The reaction at B is given to be 1.25 W times L. Reaction, which is this one here. So the reaction at B is equal, this here is 1.25 WL. So it is 1.25 times W is 345 times 5 feet. Hopefully this will give us a number to match any answer unless I did a mistake. Anybody catch my mistakes? 5 times 1.25 times, it is 2,156.25 pounds. Anybody got something different from this? Or you disagree with this? Did I do any mistake here, by the way? Okay, no, that's correct. That's correct. That's correct. Any question about this? So this is the answer for this one here.